Let's start by understanding what long welded rail, or LWR, actually means. Unlike traditional railway tracks that use short rail sections joined by fishplates, LWR is a continuous rail track where individual rails are welded together, eliminating joints and expansion gaps. This design offers a smoother, quieter, and faster ride for trains, greatly improving passenger comfort and reducing maintenance needs. However, the absence of expansion gaps introduces a significant engineering challenge: thermal stress. As temperatures change, the rail expands or contracts, which can lead to compressive stress and the risk of buckling, or tensile stress and the risk of rail fracture. Managing these stresses is crucial for the safe and reliable operation of railways. To address the problem of thermal stress in long welded rails, engineers use a process called destressing. Destressing involves releasing the rail from its fastenings, allowing it to reach its natural stress-free length at a specific temperature known as the stress-free temperature, or TD. Once the rail has settled, it is refastened to the sleepers, locking in this neutral state. This process is essential because it neutralizes the built-up stresses caused by temperature fluctuations, significantly reducing the risk of track buckling or rail fractures. Destressing is a carefully controlled operation, and the correct stress-free temperature must be maintained to ensure long-term track stability and safety. Destressing isn't a one-time process. It's required whenever the rail's temperature moves outside the permissible range for the designed stress-free temperature, TD. For example, after laying new LWR, destressing is mandatory before opening the track to traffic. It's also essential after any rail fracture or repair, since cutting and welding disturb the stress state. Other triggers include significant rail creep, major track geometry work like tamping or realignment, or whenever the rail temperature deviates from the ideal range. The permissible range is typically TD:PM5/Circ, and if this can't be achieved in the field, rail tensors are used to simulate the correct conditions. This ensures the track remains safe and stable under all circumstances. Safety is paramount during destressing operations. The process is carried out only during a traffic block, meaning the track section is closed to all train movements for the duration. This is a non-negotiable safety requirement. Personal supervision by qualified engineers, such as junior engineers or senior section engineers, is mandatory throughout the operation. Every detail, including the temperature during fastening time and date, is meticulously recorded in the prescribed register. Before the traffic block is granted, a speed restriction of 30 km/h is imposed, and fastenings on alternate sleepers are loosened to allow the rail to move freely. These protocols ensure that destressing is performed safely, minimizing risks to both workers and future train operations.